So then we have this question. If the tangent at P on the curve passes through the origin and then x1, y1 does not lie on the curve. So some random curve is given. So let us draw it randomly. The tangent at P x1, y1 is passing through origin. Then x1, y1 does not lie on which curve. So basically you find out the locus of x1, y1 and you can verify, I think. So what is the first condition? It lies on this curve. So one condition that you can write is it satisfies the curve. So y1 equal to x1 cube plus 3x1 square plus 5. Condition 1. The second condition is when you find the derivative at P, you will get tangent slope and that passes through origin. So slope of OP, if you find that should be equal to derivative at P. So dy by dx at P, x1, y1 should be equal to slope of OP. Slope of OP. So what is the derivative? Dy by dx, when you find out, it is actually 3x square plus 6x. If you differentiate this, you will get 3x square plus 6x. At x1, y1, it will be 3x square plus 6x1 equal to slope of OP. So what is O here origin and what is P x1, y1? Slope of OP would be y1 minus 0 by x1 minus 0. So from here you can see that y1 is equal to, if you cross multiply, you'll get 3x1 cube plus 6x1 square. This is condition 2. So you can solve 1 and 2 to find x1 and y1. So you say solve 1 and 2. And how to solve it? Directly equate the value of y1. So x1 cube plus 3x1 square plus 5 should be equal to 3x1 cube plus 6x1 square. So just equate the y1 values and try to solve the equation. This equation becomes x1 cube terms you can group. 2x1 cube plus 3x1 square minus 5 equal to 0. So to solve this clearly, you can see x1 equal to 1 will satisfy. So by trial, you can guess one root. So x1 equal to 1 is one root by trial. Rest of the roots, you can actually use synthetic division. So right here, coefficient of x1 cube, then x1 square. x1 is not there, so 0 and constant. Usually the first root you try should be a factor of this. And we already know one root, so I'll write 1. Carry this 2 down, then 2 into 1, write it here. 3 plus 2, 5. 5 into 1, 5. 0 plus 5 is 5. 5 into 1, again 5. Minus 5 plus 5 is 0. So basically, we have found one root by trial. The rest of the factors, so like if x1 minus 1 is one factor, the rest of the factors will be having the coefficients as 2, 5, and 5. So it should be 2x1 square plus 5x1 plus 5. So one of the roots you can take x1 equal to 1. The other equation, if you try to solve, so what is the discriminant? Is it negative? D is 25 minus 40. I think it is negative. So no real roots. So this you can skip. So you can take only x1 because these roots are imaginary. Take x1 as 1. And then what is y1? So from the previous slide, you can see y1 is 3x1 cube plus 6x1 square. So you can just put x as 1. This is 3 into 1 cube plus 6 into 1 square. And therefore, what is this? 9. So y1 is 1. So the point x1, y1 is 1, 9. So once you get the point as 1, 9. So what is x1, y1? 1, 9. So which curve it is going to satisfy? If you substitute in the first one, you will get 1 square plus 81 by 81 equal to 2. So this will satisfy. If you substitute in the second one, but anyway, they said it does not lie on which curve. So we cannot mark this answer. It lies on this, of course, but we want to write the curve on which it will not lie. If you substitute 9 here, 9 square by 9 minus 1 square equal to 8. It will satisfy this also. Then here y1 is, y is 9, 4x square plus 5. This is also satisfying. The only thing which doesn't satisfy would be this one because x by 3 would be 1 by 3, y square is 9, not equal to 2. So except this, x1, y1 satisfies all the 3 other curves. So fourth option is the answer because they said it does not lie on which curve. So option 4 is the answer.